Hey students, welcome back. This is 3.2, but our first video, our 3.1 review goes up now. So remember, this is on the left side of those notes we took on the periodic table. And the question is, how many families are there on the periodic table? So I'll go ahead and have you hit pause, and then I'll meet you down at 3.2 notes. All right, cool, awesome. I hope you got the answer right. The correct answer was 18. There are 18 groups or 18 families on the periodic table. Okay, so let's jump right in. I'm going to make this just a touch smaller here. Bohr model today. This is 3.2. This is page 18. Woo, we're getting up there in the pages. All right, so today, as I kind of alluded to yesterday or whenever we took notes on periodic table, is that this is all about compounds, and so we have to figure out how compounds are made, and that comes in with our mapping of our electrons, because the electrons are the ones involved in bonding. So if we jump right in here to the Bohr model was set up by Niels Bohr, and he said that the electrons went in orbits around the nucleus. All right? They went in orbits around the nucleus. So he said, kind of like the Earth rotates the sun, that's kind of what he said, but it was really about the specific energy levels, all right? And these energy levels are our layers of electrons. And they have different energies, right? Which makes sense, but they have very specific energies. He actually has a mathematical equation that's very complex, but it's so complex it only works for hydrogen, because once you get the other elements in there, or the other electrons in there, you start having to deal with repulsion, and it gets a little weird. But I digress. Let's move on to core electrons. Our core electrons are our electrons not on the outside. So these are our inner electrons. All right? Not involved in bonding. They do have a purpose, and we'll see that at the end of this unit, but their purpose right now is they're not involved in bonding, so we don't care kind of too much about them right now. All right? Then we go to our valence electrons. These are our outer energy electrons. When I say outer energy, I'm talking about outer energy level, all right? There are outer energy electrons, and they are involved in bonding. This is the key, because this is what it all comes down to. However many valence electrons will tell us how you bond, all right? So, kind of some background information. Those energy levels, we're talking about layers of electrons. So if we think back to our electron configurations, right? Oh man, that's taking us back, right? If we look at the first energy level, the only ones with like a 1, the big 1 out front, was just that 1s, right? That's from our electron configuration. Well, that holds 2 electrons. So our first energy level held 2 electrons. Now, our second energy level, or our second row, it had a 2s as well as a 2p. Remember, s can hold 2, p can hold 6, so we are now at 8 electrons. And that's kind of where the Bohr electron, or the Bohr model, works for us. We can do a little bit with a third, but we can't go too far into it, because remember, the third has that 3s, 3p, and then later, after the 4s, came that 3d, right? And so that gave us 18 electrons. And then our 4th, 5th, 6th, and 7th can hold 32 electrons, because there are 4s, there are 4p, 4d, and 4f. All right? But again, we're going to stay in these first 2 energy levels for our Bohr model, and then we'll kind of build from there. So how to do our Bohr models? It's very, very simple. The first thing that we do is we find the protons, neutrons, and electrons, and this is going to be from the periodic table, all right? And we'll see an example of that down below. Then we're going to put our protons and neutrons in the center, because remember, they are located in the nucleus, and the center is the nucleus. Then we're going to put our electrons and energy levels around the nucleus using this information from up there. And then we are able to identify which electrons are in the valence shell, because they are in the last energy level. And we'll kind of do that as we go here. So our example says, draw Bohr diagrams for the following elements and identify the valence electrons. Okay. So to make this simple, and I'm not super good at drawing circles, just by myself. I know this notability helps me do it, but we're going to keep it really simple, all right? So what we're going to do is the first thing that we have to do is we have to find carbon on our periodic table. Yikes. Remember, this 12 is our mass number, right? So that tells us our protons plus our neutrons. Sorry, my little 0 didn't go all the way up. All right. So we also know that carbon on the periodic table is 6, right? We found that pretty easily. 6 with the C beside it. Okay, so in our center, this is how I want us to start. I'm going to draw a circle for the center. I love how Notability does that for me. So I'm going to put 6 protons. Just say 6 protons, 6 neutrons, right? Because 12 minus 6 would give me my neutrons. All right. Now, again, to keep it simple, like I said, because I can't draw circles very well, we can just put half shells, right? And our first shell, we know, can hold 2 electrons. So I'm just going to put 2 dots in there. All right. You could also use X's. That works as well. So I've placed 2 of my 6. Remember, protons and electrons for right now are equal. So if I have 6 protons, I have 6 electrons. So now the second energy level can hold up to 8, but I only need to place 4. So kind of wherever you want. 1, 2, 3, 4. If we check ourselves, we can see 1, 2, 3, 4, 5, 6. There are 6 electrons, 6 protons, 6 neutrons. Awesome. Our last thing that we need to do is identify our valence electrons, and these are valence because they are in the outer energy shell. All right? Okay, awesome. Let's try one more, and hopefully my Apple Pencil doesn't die on me, but we can do it. All right, so we find sodium, Na. We find it on the periodic table. It's number 11. Sorry to make that jump for you. Number 11. So in the center, oh, we made an oval. There we go. A little better on the circle. Okay, so it's going to have 11 protons, but this time 23 minus 11 is 12 neutrons, right? And now for our electrons, this is our first energy level. Remember, 2 electrons fit in that first energy level. 1, 2. All right, our second energy level. We can fit 8, so 1, 2, 3, 4, 5, 6, 7, 8. Awesome. So now I've placed 10, so I've got 1 more to go. And then there's 11. All right. And if we identify this is our valence electron, there's only 1. All right. Awesome. See you next time.